Okay. So, hello everyone. I'm Kailash, PhD scholar from NanoDC Lab IIT Gandhinagar, and welcome to live session 11. And we have this session every week, and this is the second last session we'll be having on the digital circuit course. All the videos of the digital circuit course in the NPTEL are already uploaded, and we are having this session every week since the course has been started, such that you guys understand some of the problems or some of the concept via problems, right? And it will also help you in understanding and solving the assignments. Apart from that, the questions are taken from various competitive exams, such that you can also it will help you to crack some of those competitive exams. So we will start today's session, and in today's session we'll be mostly discussing on microprocessor 8085, and the most of the questions are actually on the microprocessor 8085, its instructions, and you write code in microprocessor 8085. Along with that, the questions will be if that is a particular if that is a particular code, what is the final output will be. Okay, so before starting today's session, let me ask you guys, so because the questions will be solving on microprocessor, what is the latest processor you know? Can you type on the chat box what is the latest processor you guys know? It can be mobile processor, it can be a laptop processor, but everybody type. The question is, what is the okay ARM processor? Okay, anybody else? Whatever laptop and mobile you are using, it will have some kind of processor, right? Can you type what processor do you have? Or yeah, Intel i3. Okay, apart from that, others? Snapdragon. Okay, so Khalil is answering all of them. What about others? Ryzen. Okay, MediaTek, Dimensity, AMD Ryzen. Okay, yeah. So, see, it all started way back in 1970s, when in the 1974, I think one of the 1970, the Intel 4004 processor has come, and Intel in 1974, Intel 8080 processor has come, and then after that, one of the architecture that has been defined was 8085, and then 8086, and then many of the companies apart from Intel have started building their own processor. Intel is one of the market leaders in the processor design. Till maybe last 5 to 6 years, Intel had literally a monopoly in the processor design arena. So the famous processor you might know was Intel i3, i5, i7. If you know, early in the early days, there were Intel Pentium processor, Intel Atom processor for the mobiles, and Intel had their own dual core processors and all. Apart from that, there are processors from AMD. AMD is another company which is one of the competitor right now. And whenever you go and buy a laptop, if you will see, uh, you will find the processors are either of two categories, right? Either it is an Intel processor, which can be i3, i5, i7, and i9, obviously, with different generation, 8 generation, 10 generation, and 12 generation. Uh, Apart from that, you will have Ryzen, okay, AMD Ryzen. So AMD Ryzen you will have, okay, and Ryzen 3, Ryzen 5, right? You will have a various sort of processor like this. So these are in laptop arena. When we talk about mobile processors, many of you might be using Exynos. So this is from a Samsung in-house processor. Okay, many of the Samsung phone contains Exynos processor. Many of the phones also contain MediaTek, right? So MediaTek is another company which design mobile processor. Apart from that, the most famous one in the mobile processor is the Snapdragon from Qualcomm. Okay, so if you buy any high-end phone, there is a very high chance that it can be one of the Snapdragon processor from Qualcomm. Okay, so see, processors are everywhere, right? So and today in this session and in the digital circuit lecture also, it was you've been taught with 8085. It is one of the most basic processor, right? So if you will look the instruction set of today's processor, it can be very difficult, right? But to understand such a complex processor, we have to start from 8085, right? Many can argue that why we are discussing about 8085 over here when such highly complex processors are available over and you should teach those, but it doesn't work that way, right? Because you have to understand the basic first, how the basic processor works, and then you can start on building on the top of that. Okay, so all the processor can follow cross 86 architecture, right? 8086 architecture, or it can be R, okay, or it can be RISC V. Okay, so you might know all of this: Intel, AMD, Ryzen, and Exynos, MediaTek, Snapdragon. But there is one of the processor which is indigenous to our country. Okay, and in the last 5 years, it has done a wonderful progress. It has been employed in many of the embedded system, and this processor is from actually from one of the IITs. The IIT's name is IIT Madras. Okay, IIT Madras. And anybody knows what processor I'm talking about? Anyone? Anyone know which processor I'm talking about? It is the processor is called Sakti. Okay. So we have our own. The India has our own processor. Sakti is one of the first processors which is commercially available, and there are various marathons also going on, hackathons also going on using Sakti processor. You can design various kind of solutions. It's an open source processor, right? That's the beauty of it. You can download it and you can start using for your own purpose, right? It is based on RISC-V architecture. Okay, so in today's class, we'll be solving some of the questions which are based on how the processor works and what is the instruction set it uses, what are the registers it has, what kind of addressing mode it has. Okay. Uh, Before starting, I wanted to give you this kind of overview such that you understand the importance of this topic, right? Why microprocessor is being taught to you guys in the digital system course, and yeah, I think you have enough motivation because we are surrounded by processes everywhere. Okay, so let's start today's lecture session, the tutorial session, and the very first question which I have is, how many flags are there in 8085 microprocessor? Anybody has the answer? Please type on the chat box. You have four options: 3, 5, 7, 6. How many flags are there in 8085 microprocessor? Anyone? Khalil is saying B. He's saying that okay, we have five flags. What about others? Nishant is also saying five. So yeah, you are also saying B. So the answer to this question is actually five, right? And let me show you what are the flags which are available. Okay, so actually flag is an 8-bit register, right? So many of you might get confused that whether do we have an 8 flags or do we have an 5 flags. Okay, so the answer is actually five. So we have three don't cares, okay, in this flag register. Okay, so these five flags are S. S stand for sign, and sign is set 1 if MSB of the result is 1. Okay, so if whatever data you are taking, if the MSB in 1, it means that this is negative, and sign bit equal to 1 means it is negative. Okay, Z is a zero flag. Many a times we require this zero. Okay, and we will understand in one of the examples, right? So whenever the result which of any operation comes out to be zero, right? So Z becomes one. Okay, this Z becomes one. Okay, and then there we have an AC flag, right? AC is an auxiliary carry flag, right? So see, there is one thing that is called as carry. Carry comes when you have an 8-bit data and the MSB and when you add two 8-bit data, and the final result is not of 8-bit, rather it is of 9-bit. That's a carry. But in an intermediate state, from the third bit to the fourth bit, right? So if you have an 8-bit, and from the third bit to the 4-bit, if there is some carry which is being propagated, uh, then we this auxiliary carry flag becomes one. Why this is important? Because many a times we require high half words, okay, which is not of 8-bit, rather it is of 4-bit, okay, and at that time auxiliary carry is required, right? Then there is a P flag that is called as parity flag, okay. Parity flag is set when the number of ones in a number is even, right? So if I have a number, 8-bit number, 101 101 and 1 and then 0. So how many number of ones we have? 5, right? In this particular case, the parity will be 0, right? If I had a number 101 101 1, in this case the parity will be 1, right? So it's an even parity. Becomes 1 that if if the number of ones in the number is actually even. Okay, many a times it is required. And carry is obviously carry. Whenever you perform any addition or subtraction operation, if you get a carry or a borrow, the carry flag will be set 1. The carry flag will be set 1. Okay, so now you will understand that, okay, we have 5 flags, and what is the working of each of the flags. Okay, is that clear, everybody? Is that clear?
Yes, sir.
Thank you. We will move to the second question, and again a simple one. So there is one register that is called as program counter, right? And you have to tell me what does program counter stores, right? I have four options. The first one is address of the current instruction executing by the processor, right? So whatever the processor is currently executing, it stores the address of the current instruction. The next option is the address of the previous instruction which has been executed by the processor. Okay, so the previous instruction, or the address of the next instruction which is going to be executed by the processor, right? Or none of the above, right? I have three options: the current instruction, the previous one, or the next one, or none of the above. Anybody wants to answer that? Khalid is saying the answer is A, the address of the current instruction. Anybody else? C. Okay. Neeli Sethi Komali is saying that the answer is C, that the address of the next instruction to be fetched from the memory. We have two options, A and C. What about others? Okay, so let me answer you. The answer is actually okay. Usha is also saying C. So majority, obviously majority wins, and the answer is C. The main job of the program counter is, okay, whatever the next instruction is to be executed has to be stored somewhere, right? Otherwise a processor will, how will it know that what is the next instruction to be executed? And just to take care of that problem, program counter actually stores the address of the next instruction, right? So whenever the instruction is being executed by the processor, the next instruction's address is already ready with the program counter, such that the operation just keeps on continuing. Okay, so that was the second question. Third is I have four instruction given over here, right? LDAX, LDAXH, LDAXD, and INRM, right? So load from B, load from H, load from D, and increment M. You have to tell me which of this is not a valid instruction. Anyone? Anyone wants to tell me which of this is not a valid instruction? Khalil is saying D, INRM. What about others? Janki is also saying D. What about others? All three look similar, so that is the reason why I think you do not have any confusion over here. But the answer is not D. The answer is not D. Okay. Janki is saying C. Okay. Answer is also not C. The answer is actually B. Okay, please understand and please note, whenever you talk about B, D, and H, you are not talking about only a register, rather you are talking about a register pair. Okay, register pair. It means whenever I talk about B, I'm actually talking about B and C register. Okay. Whenever I am talking about H, when I am talking about H and L register, and whenever I am talking about D, I am talking about D and E register. Okay. And please note that LDAX operation only works for BC pair and DE pair. Okay. It doesn't work for HL pair. Okay. So that is the reason why the answer is B over here, not C or D. Any confusion, anything? LDAX operation only works with BC and DE pair. It doesn't work with HL pair. And INR is a valid instruction. Okay, it does increment M. So moving to next question. See, I have two operation compare. Okay, or compare immediate. You have to tell me which of this instruction or which of this flag. Right. So we have already seen four flags. Right, and rather five flag auxiliary carry also. You have to tell me which of these flags will not be affected by compare or CPI instruction. Please tell me. Anybody wants to answer this? D. Okay. Neely said, okay. Two people are saying it is D. What about others? Khalil is saying C. What about others? Okay. So the answer is actually D over here, right? So only the parity flag is not been updated by the compare or CPI instruction. However, the sign, the zero, and the carry flag can get set. Okay. So so the answer of this question is D. Okay. Moving to next question. Question number 5. So please understand this question. Okay. What will happen to the content of the stack pointer in 8085 after a push instruction is executed? Okay. So I can write a push B, right? So push also works with uh, register pair. Okay. So if I write say push B, what will happen? The content of the stack pointer will be incremented by 2. The content of the stack pointer will be decremented by 2. The content of the stack pointer is will be incremented by 1, or the content of the stack pointer will be decremented by 1. Komal is saying D, Khalil is saying A. What about others? Any other option? Okay, Janki is also saying A. Nishant is saying B. Okay, so let's see what the answer is. Okay, so see, this is how the push instruction work, right? See, push instruction always work with the register pair. Okay, so first you will push in B and then you will push in C, right? So pushing into a stack pointer means you have to decrement the stack pointer first. Okay, so such that you have the address available, you decrement stack pointer, so SP equal to SP minus 1. Okay, and then copy the content of the register B to the stack pointer. Whatever you have in register B, you will just copy it to stack pointer. Right, now the address is full. Right, you again decrement SP. Right, and then you copy the content of register C. You might ask, where is this register C coming from? So the answer is this B is not alone. Right, B, whenever I write like this, please understand that it is always a register pair. Okay, so you will write the content of the register of the C into the stack pointer, right? So SP has been decremented once and twice, right? So the answer is B, right? The content of the stack pointer will be decremented by 2. Okay. So any question on this? Is that clear?
No questions, sir.
Thank you. Moving to next question again. Okay. So you have to tell me what is the total delay produced by the following program. Okay. So you have to assume that the 8085 microprocessor is running in 2 megahertz. Okay. And this is the instruction. Okay. So let me just write the instructions for you. MVI C, right? So OE in hexadecimal. Then you have a loop over here. Okay. Then you write decrement C. Okay. Then you write jump not equal to 0 to loop. Okay. So what this program is actually doing, it is copying the value of 0 E into C. Okay. So that is the first thing it does. Then it decrements C, right? So see, the value of C is E. E means 14, right? So it will decrement C. So it will become 13. And it will check whether the value of whatever C it is it 0 or not. It is not 0, so it will go to loop. It will again decrement, so 14, 13, 12. It will just keep on doing that unless it becomes 0, and it will exit out of the loop. So the program does that. Okay. So you have to tell me what is the total delay, how much time it will take from here to the here, right? The final instruction to be executed. We have four options: 100 micro, 65, 66.5, and 74 microsecond. So I think I will solve this problem for you. Okay. So see, before approaching this problem, you should know that, okay, how much T states every instruction take. Okay. So MVI is a 2 byte instruction. Okay. 2 byte instruction MVI, right? DCR is a 1 byte instruction, and ZNZ is a 3 byte instruction. Okay. There is a general rule you just remember while solving this kind of problem. Whenever, and you just go and see over the instruction set, right? Whenever you have the 1 byte instruction, it takes 40 states. Okay. Whenever you have 2 byte instruction, it takes 70 states. And whenever you have 3 byte instruction, it takes 10t states. Okay. Or 10t time. Now, using that, we will try to answer this question. Okay. So you see, uh, you understand that, okay, the first statement will be executed only once. Okay. I will just remove it. I will just remove it. Okay. The first statement will be executed only once. Okay. And this statement, these two statement will be executed 14 times. Okay. So 70, okay, plus these two statements will be executed 14 times. Okay. So see, the jump not equal to 0. There is a trick in this particular part. Whenever the condition, and this you have to remember, whenever the condition J and Z is true, okay, whenever the condition J and Z is true, okay, what you have, it takes actually 10t states. Okay. When it is false, it takes 70 states. Okay. So in every time, whenever it is coming over here, it will only jump to loop when the condition is true, right? And it is saying that jump not equal to 0. Okay. So see, only for one time when the condition becomes true, it will become, sorry, the condition become false, right? It will just come out of the loop, right? So see, the loop has to go up to 0 times. That means 14 times, right? And out of 14, 13 times 10t state will be taken care. So you will have to write 13 multiplied by this 4t plus 10t. Okay. And one time only 70, right? So the 40, one time 40 plus 70 will be taken. Okay. So if you will add up all of this, right? So this will be 11t, right? this will be 17t, right? And then the other will be 182t, right? So this will be 182t. Okay. So the total answer will be actually 200t. Okay. Now, here the question that has been asked is not in terms of t states. Rather, the question has been asked that how much time it will take. Okay. So, in this question, the frequency has been given over here. Okay. So, before going to that, I will just quickly revise what I have done. Right. What I have said that 70 it will be executed only once. The other statement will be executed 14 times. Out of 14, 13 times Z will take 10t time, right? And one time it will take 70 because the condition become false, right? So that is the reason why I multiply by 13 into 40 plus 10t, and 1 times 40 plus 70. The overall it will be 200t, right? Now I have to put the value of t, and t is how much, right? It is 2 megahertz, right? So it will be 2 megahertz. So 200 divided by, so you multiply by 1 by 2 into 10 to the power 6. Okay. So it will be 200 divided by 2. It is 100 into 10 to the power minus 6 second. This will be equal to 100 microsecond. Okay. So the answer is what? Answer is 100 microsecond. So answer is A. Okay. 100 microsecond. Just look into this slide and just tell me if you guys have understood or not.
Hello, sir. Is there any exceptional condition for 3T? I mean, you just mentioned 4, 7, and 10T. What about 3T?
What about 3D? No, no, no. It is 4, 7, and 10. So this is the general. Yeah.
Oh,
Okay. It is 4, 7, and 10. Yeah. Only the exception for jump and node zero loop, I have discussed that, okay, it will be like this. Okay. So one instruction in one time, it is taking 10t and 70. And these kind of questions are actually favorite to all the examiners and they give. Okay. So if, do you guys understood? What about others? Just comment yes. Okay. If you guys have understood. Okay. So what I will do is go to next part, next question. Right. Again, a very simple one. How many T states are required to execute following instruction? So see, it is an LXI instruction. Okay. Anybody knows the answer? How many byte instruction it is and how much time it will be? Because if you know how many byte instruction it is, the answer is the straight away. So LXI is a 3 byte instruction. Okay, Khalil. So yeah, the LXI is a 3 byte instruction, and I have said that if instruction is a 3 byte, the answer will be 10 T states. Okay, so how do you calculate how many byte instruction it is? You just go into your data sheet, you just see over there. Okay, you will understand. Okay, so if you know how many byte instruction it is, and you will quickly answer this kind of question. Okay, it was a very straightforward question. Moving to not more straightforward question. Okay, so see, there is a program written over here. Okay, this is the program, and please note that in the following 8085 assembly language program, assume that carry flag is initially reset, right? So carry is zero. Carry is zero. What is the content of the accumulator after execution of the program? Okay, so we have to execute this program. Move A to 4, then right shift. Okay, then move B to A, then left shift, then again left shift, right? Then add B, it means add A equal to A plus B. Okay, then right shift, right? And what is the answer, right? I will give you 30 seconds. If you can just write down and tell me what is the answer. Okay, your time starts now. And yeah, please try if you are able to get what will be the value in the accumulator. Okay, Khalil is saying B. What about others? Anybody else? I need one more answer from anyone. Okay, so let me solve it for you. Okay, see, whenever I write move a equal to 0 for h, okay, so a becomes 0 for h, that is simple, right? Then what we have written is RRC. Okay, RRC means right shift. So let me write this in binary, right? So this will be 0 0 0 0, then 0 1 double 0, right? And you right shift this by 1 bit. Okay, so right shifting means you have to shift everything to right by 1 bit. So it will be 0 0 0 0, then 0, and this will be shifted again. So it will be here 0, then 1, then 0, right? So 1 has been right shifted. So this value will come out to be 0, then 2. Okay, so a will become 2. Then what we have written is move b to a. Okay, so till before that b doesn't had any value. We have b equal to 0 to h, and a is also 0 to h at this moment of time, right? And then what we are doing, we are doing left shift. Okay, earlier it was right shift, then we have left shift. Okay, so when we are doing left shift, it is an opposite operation. So you write 0 0 0 0, then 0 0 1 0. You do a left shift, it will be 0 0 1, then 0 0 0 0 0. So it will again become 4, right? So at this moment a has become 4. See, please note that what is the value of b, it will just remain at 0 2. Okay, you are again doing a left shift. Please note that left shift operation is a multiplied by 2 operation, while a right shift operation is a divided by 2 operation. You might have already seen, right? We had done a right shift, your result has become 4, from 4 to 4 to 2. And when you are doing a left shift, the result has become from 2 to 4. Okay, so the next value will be 8. Okay, the a will become 8. After that, we are doing add a equal to a plus b. Please note that the value of b over here is 0 to h. Okay. What we are doing is uh, add b. So add b means a is equal to a plus b. Okay. So we have to add how much? 0 8 and 0 2. Okay. In hexadecimal, right? 8 plus 2 is actually 10, but in hexadecimal it is a. Okay, and it will be 0, right? So the value of a is 0 ah, and the value of b over here is 0 2, because b has not changed, right? And now what you are doing is you are doing a right shift, right? So 0 a means 0 0 0 0 0, sorry, 1 0 1 0, right? And when you do right shift, right, this 0 will go, so it will come over here 0 1, then 0, then 0 0 0 0. Okay, so it will be 0, then it will be 5. Okay, so a will become 0 5. So after the entire step, the final value of the accumulator has become 0 5, right? So the answer over here is 0 5. The answer over here is a. Anyone has doubt on this part, how I have solved this? Anyone, any doubts?
Sir, could you repeat again, sir?
Repeat again. Okay, yeah. So let me repeat everything again, right? So everybody listen, who has uh, if you have missed anything while I was explaining in the first part. Okay, right? So whenever I write MVI a equal to 0 4, it means the value of a becomes 0 4h. Okay, so I think that is clear. Now what you are doing a right shift, right? So this means, what does it mean? It means a is a right shifted by 1. Okay, so whenever I do a right shift, so right shift operation is happens like this. Okay, 0 0, sorry, 0 1 double 0, right? And you are doing a right shift, so this one will come over here, and this will be 0, right? This will be 0 0 0 0, then 0 and again 0, right? It will become 2 instead of 4, right? So this has become 2 over here. 02H, right? Up to that, everything is fine, right? And up to this, only the value of A has been updated. Now, what we have done, move B to A, okay? So A was 02H, so B has become 02H, okay? A is already 02H, right? So A and B are like this. Then what you're doing a left shift, okay? Left shift on what? So whenever you write this kind of instruction, these are called implied instructions. Okay, implied instruction means the instruction and everything has been implied on it, and the address has been implied on it. And here it means that whatever is the value of accumulator, you shift it to left, right? What is the value of the accumulator? It is 2. Okay, so accumulator has to be set at left. So 0 0 0 0 0 0 0 1 0 has to be shifted left. It means 0 0 then 1 then 0 0 0 0 0 0. So it will be 0 then 4, right? So after this step, what happened that B remains at 02H, but A has changed to 04H, right? Again a right shift on accumulator. So B will again be same. However, A will become 08H. Okay. After that, what we have written is add b. Add b means a equal to a plus b. Okay. That is that the instruction means that. So a is 08, b is 02. So 08 plus 02 h in hexadecimal. Okay. So 8 plus 2 is 10 in binary. Sorry, decimal. In hexadecimal, it will be a and 0. Right. So a will become, sorry, b will remain 02h. However, a will become 0ah, and after that you have done a right shift, right? So let me write a 00001010, and you do a right shift. It will be, so it will move like this: 0 is there, this 0 is there, then 0 0 0, okay, then 1, then 0, then 1, right? So this 0 will be gone. Okay, so it will be 0, then it will be 5. Okay, so the final answer will be 05. So the answer over here is a 05H, right? Is that clear now? Okay. Now, moving to next question. Again, question on we have instruction LXI H 1234H, right? Then DAD H, then PCHL. So, what has been written on the question that all the addresses and constants are in hexadecimal. Okay, so these are in hexadecimal. Let the program counter be the contents of the program counter. Okay, the PC be the contents of the program counter, while HL be the contents of the HL register pair. So this is fine, right? We know that PC means program counter and HL means the content of the register of the HL pair, right? Which of the following statement is correct after executing this, right? So you have to execute this and you have to write down that which of the following instruction is correct. Anybody wants to answer this? Okay, so let me answer it for you. Okay, so it happens like this. Okay, so whenever you write LXI H1234, it means, see, H is not alone, right? It is an HL pair, right? So in HL pair, H will go to the upper half, that is 1 2. So 1 2 in hexadecimal, and L will go to 3 4 in hexadecimal, right? So this is clear. Now the value of H equal to 1 2 and L is equal to 3 4. Okay, after this, now what you have to do is a double addition. DAD means double addition. Okay, so here DADH actually means, what? Actually means it actually means HL equal to HL plus HL. Okay, so what we are doing is we are adding 1 2 3 4 with 1 2 3 4. So let me write, okay, 1 2 3 4 to 1 2 3 4, right? This is H, this is L. Okay, and the final value will be 4 plus 4 8, 3 plus 3 6, like 2 plus 2 4, 1 plus 1 2. Okay, so after this step, H will be 2 4 and L will be 6 8. Okay, so HL will be 2 4 6 8. And PCHL means whatever the value of HL is, just copy into program counter. Okay, so now PC will be 2468. Okay, so the value of PC after this is 2468 and HL is also 2468. Right, so the answer here is C. Right, the PC is 2468 and HL is 2468. Is that clear, everybody? It was extremely simple. Okay, H, LXI H means you put the first part in H, the second part in L, done. Then you add HL2 with HL and store in HL, right? That part is done over here, right? And then you copy HL into program counter, right? So that part is done in here. So see, this statement means that PC and HL are same, okay? So we have to just see what are the options which are same. So we already have the answer. But what is the exact value we got from here? 2468. So the answer is 2468. Is this clear with everybody? Is
Yes,
that
sir.
clear? Moving to another question. Uh, Here the question states that what are the content of the accumulator after execution of the following program, right? So we have another program, okay, and you have to find out what will be the value of A after this. Okay, so to approach this problem, uh, again very simple, right? So you write move A to 4EH. It means that A is equal to 4EH, right? So after first step, if anybody asks that what is the value of accumulator, it is 4EH, right? See, please note that this small h is in it does just denotes it is in hexadecimal. Okay, now what you have written is move B to 10H, right? So at that time, what is the value of B? We don't know, right? After that, we have written move B to 10H. So A is 4EH and B is equal to 10H, right? And then we have written A and a B, right? So what does it mean is and A to B. Okay, so it you have to do like this: A equal to A and B. Okay, so see the value of B won't change over here, so B remains at 10H, right? Now A is A and B, it is bitwise AND. Okay, please note that it is a bitwise and I will write and I will explain how the value of A will come. Okay, so see what is A is 4E. 4E means 0 1 0 0 1 1 1 0, right? So this is 4 and this is E. And what is B? B is 10, right? So 0 0 0 1, then 0 0 0 0, right? And this operation or this AN means bitwise AND, okay? Bitwise AND, right? So this is A, this is B. This will be A equal to A and B. And let us see what will it happen. So 0 and 0 is 0, 1 and 0 is 0, 1 and 0 is 0, 1 and 0 is 0, 0 and 1 is 0, 0 and 0 is 0, 0 and 1 is 0 and 0, right? So the answer is 0 0, right? After this step, the value of B remains same. However, A is 0 0H. Okay. Then XRAB. Okay. What does XRAB means? Okay. So what does XRAB means is A is equal to A XOR, right? A XOR B. Okay, what is the value of A? All zeros. What is the value of B? 1 0, right? So let me write A equal to A XOR B. Okay, I do not have place over here, so I am writing over here A is equal to A XOR B, XOR B. Okay, and let me write A is 0 0 0 0 0 0 0 0. B is 0 0 0 1, then 0 0 0 0. Okay, and you have to perform an XOR operation. Okay, this is B, this is A and B, this is A XOR B, which has to be pushed in A. Okay, whenever the value of XOR is same, the answer is 0. Whenever the value is different, our answer is 1, right? So for this, it is 0, then 0, then 0 0. Here it is different, it will be 1, then 0 0 0 0, right? So it will be 1 then 0, right? So A is 10H, right? So many of you have already given me the answer. The answer here is C, that is 10H. I hope the explanation was clear. Uh, Please confirm if you have understood what I have explained. What about others? Okay, thank you. Uh, Moving to another question, which is a very simple one. Okay, very simple one. Okay, so see, initial value of a is 0 fb. So a is equal to 0 fb in hexadecimal, and b is equal to 1 2 in hexadecimal. Okay, the answer is, sorry, the question is actually, when you execute this operation ORA B, right? So let me tell you, ORA B means A is equal to A OR operation, okay, B. Just like what we have done bitwise and bitwise XOR, it is a bitwise OR, right? After executing this operation, what will be the value of A and B? Anybody wants to answer this? It's a very simple one, very simple one. Without solving, you can answer. Anyone? See, the very first thing is B is going to change? The answer is no, right? Because A is only changing. So the B will remain 12H, and there is only one option with 12H. Okay, so the answer will be B, and let me explain what will be the value of A. A is A or B. Okay, so if I write 0 FB, 0 FB will be XORed with what, 1 2. Okay, so let me write in binary. It will be 0 0 0 0. F is 1 1 1 1. B is 1 1 0 1 1, right? So this will be B, and 12 is 0 0 0 0, then 0 0 0 1, then 0 0 1 0. Okay, and it's an OR operation. So the answer will be 1 or 1 is 1. This OR is 1, right? There won't be any carry as such, right? Because it's an OR operation. 0 or 0 is 0, 1 will be 1, right? Here it will be, because all are 1, right? So 1 1 1 1, and all are 0, so 0 0 0 0, right? So it is 0, this is F, and this is B, right? So the content has not changed even after ORing with the value. Okay, so the answer remains A equal to 0 FBH and B equal to 1 2H. Is that clear, everybody?
Yes, sir.
So moving to next question, again a very simple one. Uh, what is the content of the accumulator after following instructions are executed? Okay. See, it's a very interesting operation which is happening, but it's a very simple one, right? Move A to 12H, then CPL A. CPL means complement. Okay. So CPL here means complement. Complement is again a bitwise operation. So if you have a value 0 1 0 1, then 1 0 1 0, when you apply a complement operation, it will be 1 0 1 0 0 1 0 1, right? So it will be a complement. And then what you are doing over here is add A to 0 1, right? So here A is equal to A plus 1, right? So what is the operation happening over here? And do you have the name for this operation, whatever that has been happening over here? Anybody? Okay, Janki is saying it is EE. Can anybody tell me? Okay, Khalil is saying also EE. Can anybody tell me what is the standardized name of this particular operation? Anyone?
Two's complements.
Yes, right. So excellent. So the operation over here is nothing but a 2s complement. Okay, so you see it is first complemented, one is complemented and added with one, right? So this is a 2s complement. Okay, so I will write A as 0 0 0 1, then 0 0 1 0, then I will take a complement of this, so it will be 1 1 1 0 1 1 0 1, then I will add 1, right, plus 1, right? So it will be So 1 plus 1 0, it will be carry will go to over here, right? It will be 1, and the other values will remain 0 1 1 1 1. Please note that it adds like this, okay? 0 0 0 0 0, right? So it will be E, and this will be also E, right? So the answer is B, okay? EEH, hexadecimal. So we have moved to question number 12. We have two more questions. Let me move to the 13th one. Which of the following instruction is an example of implied addressing mode? Okay, can you quickly tell me which one is implied addressing mode? Khalil is saying C. What about others?
A.
Okay, so we have two options. What about others? C. Okay, so see, MVI B has 9 at H, right? So what you are doing over here, you are storing the value of 9 at in B, right? This is called as what we call as immediate addressing mode. Okay, this is immediate. So this is not implied. This is immediate addressing mode. Addressing mode. Okay. Then what we have is whatever the content of the address is there in the memory, right? So if this is the memory address, whatever the content is being added to the accumulator, and this mode is what we call as direct addressing mode. Okay, direct addressing mode. Okay, this is also very same to MVI. Okay, or I A2 has 45H. Okay, so if you see this instruction, right? So this instruction is also an immediate one. Okay, implied addressing mode means there is no addresses which is explicitly specified. However, uh, the instruction will take care of whatever the instruction has to be executed, and this is what we call as implied, because in earlier one of the example I have said that the CMA means A is not of A, right? But nowhere it has been written that what address and what value you have to do. It has been implied in the instruction itself. Okay, so the complementary instruction is one of the kind of an implied instruction. The other implied instruction are RRC and RLC, right? So these are also implied instruction. Why? Because you write A is A right shifted 1, and you write over here is A equal to A left shifted 1 without writing 1 or left shift or A anywhere. You just imply that, okay, whatever the value of the accumulator is, you do some operation on that, right? You either complement it, you either rotate, right shift it or left shift it. Okay, so this is the 13th question, and the 14th is this one. What are the content of the register B after the following instructions are executed? It's a very simple one. Please tell me what will be the content of the register B. Quick. Khalil is saying
B.
B. What about others?
B. B.
B. Okay. Anybody else? See, after this step, okay, Komal is saying B. Okay, so after this step, B equal to FF. FF is what? 1 1 1 1 1 1 1 1. Okay, after this, C is also 1 1 1 1 1 1 1 1, and here B value of B is 1 1 1 1 and FF, right? So, and this means B is equal to B plus 1. Okay, so let me write 1 1 1 1 1 1 1 1 plus 0 0 0 0 0 0 0 1, right? So 1 plus 1 is 0, carry 1, plus 1 is 0, carry 1, then plus 1 is 0, carry 1, then 0 carry 1, then 0 carry 1, then 0 carry 1, then 0 carry 1, and this carry will go out and it will make what? It will make carry flag as 1, right? But if you see what is the content of B, the B is 0 0. Okay, the answer of B is answer of this question is 0 0 H. Is that clear, everybody? This is a dummy instruction. It is not doing anything here, right? You're moving FF to B, right? And then you're incrementing 1. But when you add 1 to FF, the answer will be 0, right? Because the carry will be set 1. Last question is a big one, not very big. So I will explain. I won't ask you, right? So there is a 5 set of instruction which is here, and what the question says that what is the content of the accumulator after the following program is been executed, right? So how to approach this problem? We have made a table over here, and using this table, we will try to understand what will happen. Okay, so please note that after this step, this is LXI operation, and whenever B is been B is there, right? It is not only B, rather with LXI operation, it is actually BC pair, right? And whenever LXI operation is being used with B or D, it is pair, right? So B will be 0 4, and C will be 0 0, right? So please note at the iteration 1, at the very first time, B is 0 4, C is 0 0, right? After that, this instruction is done. We will go to this instruction, decrement B, right? So only B will be decremented. So B will be 0 3. What is the value of C? C is 0 0. Okay. Then move A to C. So the value of A is 0 0. What about B and C? So B is 0 3H and C is 0 0. So that has not changed, right? And then what you are doing is you are ORing A to B, right? So A is 0 0. Please note A is 0 0, and you are ORing A to B, right? So 0 0 0 0, then 0 0 0 0. Okay, then what we have done is your ORing to be that 0 0 0 0 0 0 0 1 1, right? It is 0 3H. Okay, so the answer will be 0 0 1 1, then 0 0 0 0. This will be nothing but 0 3H, right? So the value of A will become 0 3H, and B and C will remain same. Okay, so B is 0 3 and C is 0 0. Okay, so after this step, if you see what is A is 0 3, B is also 0 3H, and C is 0 0H. Okay, now the question is jump not equal to 0, right? Is the answer is 0? The answer is not, right? Because accumulator is 3, so it will go to loop again, and next iteration will happen. Please tell me if the first iteration is clear to everybody. So this is the first iteration we have gone from this step to this particular step. Is that clear? Okay, what about others? Okay, so moving to the second iteration, now things become very simple. Okay, so see, B is 0 3, C is 0 0, B is 0 3, C is 0 0. What we are doing, decrementing B, it will become from 3 to 2, right? A is move A to C. See, C is not changing, right? At any step, C is not changing, so A will again become 0. Then A is A or B. What is B? 0 2, right? When you are ORing 0 to any number, it will be number itself, right? So A will be 0 to H. Again, the value of A is 0. No, it will go again here, right? So B is 0 2, C is 0 0, right? So the instruction decrement B will be executed. B is 0 1, right? A is again move A to C. It will be again 0 0. So it will, the instruction will be repeated. Then what you are doing is A equal to A or B. So B is 0 1, A is 0 0, A or B will be 0 1. It will go to next step. B is 0 1, C is 0 0, right? So you will decrement B. It will be 0 0. Okay. A is move A to C. C was initially 0, so it will again be 0. Now you are ORing 0 with 0. The answer is 0, right? So the answer is 0, and it will just come out of the loop. Okay. So what is the final answer? A is 0 0, right? So the final answer of accumulator is D. The answer is 0 0 H. Okay. Is that clear with everyone?
Yes, sir.
Okay. So these were the 15 question for today's lecture. We have one more. We'll be having on 8085 and 8086. Uh, I hope you guys are well preparing for your final exam, and you might be doing all the assignments. Okay, so if you have any doubts, any question, feel free to write me at kailash.prasad@itgn.ac.in. I will try to revert back in 24 to 48 hours. And please go through the 8085 instruction set, everything, and just try to solve this kind of question to strengthen your basic, right? It is one of the very important topics in the digital design. And please let me know if you have any questions over there now, right now. Otherwise, we will end the session today. Okay, some tips to clear the final exam. Go through all the slides of Professor Santanu Chattopadhyay. Okay, the second thing is go through all the assignments again. Just see if you are comfortable with all the assignments. If you have scored full, it is extremely good. If you have mistakenly not scored full in the couple of assignments, just see where you had done the mistake. Solve all the assignments again. Solve all the question which I have discussed and the other TA is discussing, right? So but just go and watch all the tutorials and of all the TAs, and solve couple of questions from the gate exam, previous year exams, that will be more much more helpful to you guys, right? If you go through whatever we have discussed on the class in the NPTEL lecture, and whatever we are given in the assignment, and whatever we are discussing over here, I think that will be sufficient to score a very good in your exam, right? The only thing is just keep practicing more and more problem. If you are comfortable with solving in the problems, you'll be easily having a very good score in the final exam. Okay, any more questions? Okay, then thank you everyone for joining. We will meet for one last time. Please join the last session of the NPTEL, the PMRF session. I hope that everybody is learning many things from this session, how to solve the problems and all. Thank you everyone for joining. We'll meet the same time for one more time uh, next Tuesday.
Thank you, sir.